Olá, pessoal do SouJava. Hello, everyone. Welcome to the to SouJava YouTube channel. So, my name is Maximilian, but you can call me Max. Okay, and today we got a good, awesome person that I'm a friend of. He's a Java champion. He handle a lot of things regarding Java. So he's a contributor open source. So he's editor, a writer. He releases a lot of books. So I will switch to Portuguese because I know that most of our audience are Portuguese ones. So, ok, pessoal, bem-vindo então ao Sou Java. Espero que vocês tenham como tá ansioso assim como eu estou um pouco nervoso aqui, porque a gente tá falando com um cara muito massa aqui, que é um amigo bem grande aqui. Então, vocês aí, se tiverem alguma dúvida, alguma coisa relacionada, pode mandar no chat, a gente vai tentar conversar aqui, trazer o Bazlur aqui para poder conversar e falar um pouco mais sobre esse assunto que ele vai falar, ok? Vou voltar para o inglês aqui. Okay, everyone. So, if feel free to send us questions on the chat. I will bring Buzzler right now. Buzzler, come in here, man. Welcome.
Hey, thank you, and thanks very much for your work. Warm welcome.
Okay. Okay. So, everyone in the chat, please send us where are you from? Where are you watching us? It's very interesting to see where are you from. Okay. But I'm from São Paulo, Brazil right now. I think Buzzler is in Toronto, Canada.
Yes, I'm
Am I
from
right?
Toronto now. Okay, let us know where are you from so that we can, relate and we can keep the conversation going and make it interactive. So, I mean, we're gonna spend 1 hour here. So, I also want to get benefited from you as well, right? I mean, I don't want to talk all the time. So, send your questions, participate in these conversations, and so that we can keep going and as a whole, as a team. So that's the spirit.
Oh yeah. Oh, in the chat, we can see it's Eduardo. It's a friend of mine. He's watching from Portugal. Welcome, Flávio André from Blumenau and Danilo from Aracaju. Okay. Flávio from João Pessoa, Paraíba, Brazil. Okay. Very nice. Very nice, guys. So I think that it's time. It's show time. I don't want to spend more time. If you can introduce yourself, Buzzler, feel free. I think that I did a little spoilers, right? But I think that you are the best one to talk to about yourself. Oh, Marcelo Busata, you are from. He's from São Paulo. He's my friend as well. We worked together in the last company. But that's okay. Buzzler, I will feel free to talk.
Sure. So I'll start with sharing my slides. So I have a slide, so don't worry about that. A slide is basically for myself, and so that I can keep track on the topic. Otherwise, it's very easy to get away from the topic and start something else, which is also fine. If you want to if you want to talk about something else, that's also welcome. So just send me your questions and I'll try to discuss about those topics, anything related to Java, anything related to concurrency per se. So yeah, I'll try my best to answer your question. If I cannot, at least I'll able to point you the direction where you can find this answer too. So yeah, so that's the idea. All right. So what I'm going to do, one thing before I start. So I'll
Okay.
move this screen to another display so that I can at least see your questions while it's coming. So anytime is fine. You don't have to wait. Anytime you can ask your questions, and I'll try to accommodate it as I go along. All right. So
Okay.
thank you, Max. I can call you Max, right? I mean,
Sure, of course, of course.
yes.
It's easier than Maximilian. Maximilian looks like you are. Looks like I did something wrong. So, but everyone, I don't know, but Buzzler, are you watching the chat? Okay, so I don't know if you prefer. Do you prefer to answer the question along the way, or you prefer to?
I'm fine. I'll keep an eye on in the chat as well. If the question
Oh,
is relevant to this
sure.
topic, I'll definitely jump into that that question, that's totally okay.
Okay,
And
because this is
one
professional one. I'll be on the backstage, man. Take it
sure.
to place. Do it the show.
All right, man. Thanks. So, before I you go, I wanted to share jokes about. I wouldn't say a joke. So the name, when I get to get hear your name, what I hear is Max is a millionaire. That's the kind of word I hear in my ear. All,
Okay.
all right. Uh, uh, so yeah, already Max already shared a bit about me. So I'm not going to bore you all of this. I am a Java user group leader, so I like to talk about Java and Java user group and community. So community, working in a community is really exciting because that way you can learn from each other, and when we learn from each other, we share our ideas, our knowledge, we grow together. So that's the idea, basically having a community like SouJava. For example, I'm a leader of Java User Group Bangladesh, so we keep interchanging the ideas. So that's how we grow together. So all right, enough about me. So first of all, I'm going to lay down the agenda. What I'm going to talk about. Like I said earlier, you don't have to stay on this topic. Anything you can bring and ask questions about Java and Java concurrency, threading. I will definitely try my best to accommodate as much as I can. All right. So, but still, I want to lay down the the agenda, which is I'm going to talk about today about virtual threads. It's going to it's very exciting topic for me. I mean, it's still new. It's not available in our regular JDK. It's available in JDK 19, but still in the preview feature. But hopefully, in upcoming releases, we don't know when, but in one of the upcoming releases, it's going to be added in Java, so that everyone would be able to use it. So this talk is more of a so that you can go ahead and try it out. You learn it a bit early, so that when it is available, you can directly apply to your code. So that's the idea. All right. So first of all, before going talking about the virtual threads, I think it's important to give you some ground knowledge. I mean, what is all thread about, right? Why do we need threads, and what do we care about it? Or as a Java programmer, do I need to care about thread programming, right? So that's the idea. So I'll start from there, and I want to put a question to you. What do you think about threads? Do you think it's a dreadful topic? Fear do you have a fear of concurrency? If it is, let me know in the chat, so that I can try to we can share the same sympathy. Uh, you know, so write in the chat what do you think about concurrency. All right. So, Java, one of the main reason Java was popular, and now it's popular now even, is it introduced the concurrency model from the day zero. So whenever you write a piece of code in Java, it's executed by a thread. Even if you don't deal with threads, let's say you are doing a Java application, you never deals with concurrency. Still, it's being executed or run by a thread. So that's the fundamental thing. You can call it an execution environment. So whenever you write a piece of code, it needs to be executed, right? Someone is responsible for this execution. Say you start a curly brace, and then you start end a curly brace, and in the block of curly braces you put some code, and those code are executed by some entity. This entity in Java is called thread. Okay. So the idea is, if we have more thread, that means more than one. That then we can call it this whole program. I mean, the program we are executing or writing, we can call it multi-threaded program, right? So more thread basically means is a more execution environment. So this the benefit of having more execution environment is, in a program multiple things can run simultaneously. Let's say you have an execution environment over here, you have execution environment over here. So you can run two set of program in two different execution environment, and they can sometimes run parallelly, and they can sometimes they do context switching and other things. We'll talk about that later. But from the very beginning, think about it, the mental picture. Thread is like an execution environment, and we put code into that execution environment, which is basically gets executed, and we see the result. So the idea is more, if we have more uh, execution environment, that means we can run more things simultaneously. So that's the basic idea. Let me know if you have any questions so far. I'll go ahead with the with the very basics, which is how we usually create threads nowadays. Even in the initially when we used to, I mean, like 25 years ago, we used to write threads. We have a thread class. We write threads nowadays with a lambda expression, but pretty much it is similar. So the idea is, we extend a thread class, and then in the constructor we provide runnable, and the thread then gets executed. Whatever code we put inside this runnable get executed. So that's the idea. If I can do a quick demo, I think that would be interesting, right? So let's see if I can give you a quick demo. So this is the idea, all right? So whenever, so like I said earlier, if I start with this curly braces and then end with this curly braces, that means anything inside this block of code is going to run by a thread. So we can easily find that which thread I am running on. For example, if we call this method, then it will print which thread I'm running, and then let's say I'm gonna block in a comment error this for a second, and then I'm gonna run it and see what is the output it returns. So you can see over here it says I'm running on main thread. So any application will start with the main method, start with the main thread, right? So that's the one thread. But from that thread, we can create another thread or any or many other threads as well. So this example is going to do exactly that. So over here, I'm creating instance of new thread, and over here I pass a lambda expressions. But what I can do is I can also new do a runnable interface, basically implementation of runnable interface, and I can provide over here. So let me copy this line over here so that I can see, I can get a print that it's indeed running by another thread. So for simplicity, I'm gonna remove this and put in the lambda expression so that it looks nicer in this screen. So I can name it whatever name I want to name it. So now that this line is going to run by a completely different thread, and if you want to start a thread, we just call it thread.start, and then we need to join over here so that main thread doesn't kill this thread. All right, so let's start and press this run button, and as you can see, this line is executed by the main thread, and then this one executed by the another different thread, which is we call it SouJava thread, right? We name it SouJava. So whatever we name it, we can name a thread anything by setName method. So all right, so that's the quick demo, and that's how we create threads. All right, so and the thing is, whenever we create a thread, it's not basically Java thread. It's more of a operating system thread. So operating system allow us the way to So the idea is whenever we create a new method, a new dot thread, it asks operating system to create a new thread. So basically, Java doesn't have a way of creating thread. We could say it's more of a wrapper or a thin wrapper of a operating system thread. So that's the idea. If you can whenever you are running a thread, if you do a thread dump, you'll see there is a ID, which is basically operating system ID, and that's where you can validate that this thread is basically a operating system thread, not created by a Java. Java itself or JVM. So that's the idea. All right. So far, let me know if you have any questions so far. All right. So now the problem is, the creating threads like this way is pretty much expensive operation. The reason is, there are several reasons. First of all, it whenever we create a thread, it's create a thread outside of the heap memory. Let's say your computer has a four 10 gigabyte, 10 or 8 gigabytes of memory. Let's say it, and you give that Java process 4 gigabyte of heap. Now, whenever you want to create a new thread, it's going to create a new thread outside of this heap memory, right? And it requires thread basically an execution environment. Whenever a method is executed by a thread, it requires to store all this information to a stack. So that's why it's required extra memory, and it's created by a off heap area. So so usually in Linux, if you create a new thread, it takes about like 2 megabyte of memory. So now think about that. If we need more thread, that means we need to have more memory outside of the heap, right? And so also another thing is, in operating system, we have a limited set of core, right? Let's say my computer has a 10 core, and one core at a simultaneously, but at a point of time, can run one thing, right? So there will be a lot of context switching. Let's say I have thousands of threads. That means, and I have only 10 core. So 10 core will be distributed by this, uh, you know, by these all 1,000 threads is going to be distributed by this 10 thread. Every thread is going to be context switched, right? And context switch has a cost as well. So that means, let's say if you want to create 1 million of threads, that would require of it like 2 terabytes of memory, right? Because one thread requires 2 megabytes. That means if you calculate, you'll figure out that it requires 2 terabyte of extra memory, off heap memory. That's a huge memory, right? How many what is your on your computer, what is the memory size of RAM? Tell me in the chat so that I can I can relate whether we can do that or not. So all right, let's go. So from this discussion, whatever we figure at least one thing, which is trade is really expensive, and we cannot create as much as we want. The question is, do you want to create a lot of threads? The reason is we sometimes want. I'll get to that. Why we need more threads, right? Okay, so let me go into the next slide. All right. So like I said, threads are limited in modern web applications. If you try to create in your operating system, in your computer, and start counting, let's say. This is a demonstration I did. I wanted to show you this, but I'm gonna just share this code to you, because if I want to run this program, there is a chance that my computer may run, I'll the Zoom, sorry, the streaming that we are doing, it may hamper, may get hampered. So I don't want to break this session, but you can copy this code and try on your computer, and you'll see, once you will run this, after a while you will see that you cannot no longer, you cannot create threads anymore. So what it does is, let me explain it a little bit. It's run a infinite loop, and inside infinite loop, it start creating threads, and it just prints the number of thread where so far we have created, and it kept blocked. The thread is basically waiting somewhere, and if you keep going, after a while you'll see that your program basically going to crash. And that's what happened. I have like 60 GB of memory, a computer, and I was able to create only 16,000 of thread. Although this number is quite high, but then 16,000 of threads is going to compete with the, let's say I have 10 crore machine, right? So 10 they're going to compete with this 10 core, and there will be a lot of context switching. So that's the problem, right? But on the other hand, The benefits is, let's think about a more modern web applications, right? So let's say we have a Java servlet applications, which is we get a request and we get served. The system is the way servlet engine are designed is whenever we get a request, a thread is allocated for that request for that particular user, and thread basically serve that particular user. So let's say I have a 100 user at a point of time, and they are sending 100 requests. So whenever and every request is basically served by one particular thread. So that means at a point of time we can serve like 100 users, right? So that's our throughput, right? And what if we want to increase it? Like I want to serve thousands users at a point of time. Can we do that? If we can have like hundreds threads, we definitely can, right? And if we have like 2,000 threads, then we can also serve 2,000 users. That's the idea. That means if we have more connections and if we have more threads, we have more throughputs. So that's why probably having more threads is important. Having more threads is beneficial. That means we all wants to our applications or whatever web applications we're writing, we want to have more throughput so that it can perform well, right? It can serve more users with the limited resource we have. So that's the benefit. The problem is, like the earlier slide I have just showed you, it doesn't work in reality. We cannot achieve that by just creating a bunch of threads, because threads are expensive and we cannot create a lot of threads. However, if we could do that, that would really solve a lot of problems. A lot of concurrent is the problems. A lot of we would be achieve more throughputs. So that's the benefit. That's the goal we want to achieve. But we are limited by the by the resource available for us. So what can we do? Do you have any solutions? Let me know if you understand the problem, right? We have in a situation where we want to achieve our throughput, but we don't have resources available for us because we are limited by the number of threads we can create it. And when we have more threads, that means we need more memory, and we will have more uh, you know um, context switching. So all of them are getting expensive. So yeah, so that's an interesting conundrum. What do you think? Um, all right. So far, whatever I have said, I have prepared a demo for you. I'll give you a quick demo so that you can have the context, and then we'll get to somewhere where you will have a solutions. Okay. All right. Let's go to the demo. And meanwhile, if you have any questions, feel free to ask me. Yeah, someone says that means 1 million threads are impossible. Well, it's true and false at the same time. And yeah, the title is a bit wrong in a way, and then it's right as well. So I'll get to you there. So if you run this program, there is a program that I can definitely share with you, which is I copied from a newsletter of Dr. Haynes Kabul. So I'll probably share that link with you. And if I can share with you, you can see I have created a 12 million of threads. So whatever I have said so far, you can think of I lied. Well, it I didn't lie. So the idea is we have two kind of threads in Java now, as at least with the invent of Project Loom, which I'm going to talk about. But before that, I'm going to show you a demo. You see, I have created like 36 millions of threads. It's a lie. This programming is lie. Why? I'll tell you later. But the count is not false. But yeah, it's a lie. All right. Let's go to the demo. let me give you a quick rundown of what I was talking about. So let's say we have a web server over here, right? So what it does is it's a basic basic program that we used to do in our university or first year or second year courses. Basically, we're going to do a stat server. This is a server socket which is going to start on port 808, and then keep listening. Whenever a request come, it will just handle. So what it does is it receives a request and it just convert it to uppercase and then serve it. So that's all it does. It doesn't do any fancy things. But ideally, whenever we use a web application, Java applications internally, this is the basic stuff it does, right? We send a request and we get served. That's what it does. So it's a very simplified version of it. So I'm gonna run it, and I'm gonna create a terminal. So what I'm gonna do is I'm gonna telnet 808, right? So if I write over here hello, I don't know if you can see it. Okay, so whenever I write something over here, I get a response immediately. So since it's an web applications, I'm the only user that I'm currently using. It doesn't make sense, right? It makes sense that I'll have more users over here. So let me open another terminal and see if I can connect to the telnet. So if I type over here, you see I don't get any response. I don't get any response. But if I close this terminal, let's say I am immediately I start getting responses, right? So the reason is this program is inherently it's a single threaded program, right? It can you see I haven't created any thread over here. So it start from here with the curly braces in the main method and ended over here. So whatever code I have written or executed from here, it's getting executed by a single thread, right? So what if I create a new thread over here, or thread, new thread. I'm gonna pass the lambda expression over here, and then I'm gonna copy this thing over here, and I'm gonna start this thread. So what I'm doing is whenever I'm getting a request, I'm creating a new thread. I'm passing it to this request. I'm passing it to that thread. That's it. And then main thread is free again to receive another request, right? So this portion of code is getting executed by a different thread. Now, if I run it, if I run it again, let's see if I can run it again. All right. So let's see. The application is running. So what I'm gonna do is I'm gonna create again telnet over here. I'm gonna create terminal over here again over here. Localhost telnet 8080. So if I type over here, you see I can get a response immediately. If I type over here, get a response immediately. That means whatever I have said so far is accurate, right? If we want to serve multiple users, we'll just handle this request to a different thread. So now if I have a 2000 users, 2000 terminal open, I can just create 2000 threads. What if I have 1 million users come to this web server? Does it mean I can create 1 million threads? If we could, that would definitely help my program, right? But like again, so far whatever I've said doesn't doesn't make sense, right? I mean, we cannot create millions because of the constraint we have, which is we have a limited we have we are going to go out of memory, and operating system doesn't allow us to create as many threads as we want. Those are the constraints. All right. So that's the reason I wanted to give you the sort of context over here. So far, whatever I have said is, if I can summarize, one is, if we can have more threads, that means we are going to achieve more throughputs. That means we are going to handle more users, but we cannot do that because threads are not cheap. It takes a lot of time, and sorry, it takes a lot of resources, and it limited by the number. It depends on operating system, the exact number, but it's not a huge, it's a limited. So keep these two things in mind. All right, so I'm gonna proceed. This is the one I wanted to show you a demo, which is, I have created a 20,000 sockets, and then I'll just send request to that program. I don't want to run this over here. The reason I'll, the computer may crash, so I'll, lose the communication. That's definitely I don't want to do. But I'll share the slides. You can do the experiment by yourself. All right. So all right. So what? So yeah. Now, you know that's the way we sort of used to used to do in our in our earlier I mean, so far before 19 we used to do code this way. So how do we solve this problem? That's where we are going to show you the virtual threads, which is interesting. Let me so I don't have this code on in the IDE, but I can give you an idea. So if we can, over here, in this example, we created a new thread on each request, right over here, which is I showed you the demo over here. Sorry, we created a new thread. Ideally, we don't create thread this way anymore. We rather create a thread pool, which is we have a framework called executors. Executors creates all the threads and cache it, or so that we can reuse, because the threads are expensive, right? So we'll create a limited amount of threads, let's say hundreds or 200, and then we'll keep reusing it with the executors. That's what we do. So so and then we keep submitting a task. Task means is basically an instance of runnable. That's what we do usually. And if we want to do the same thing with the virtual thread, we can just have to change this line. That's all we need to change, which is executor.new virtual thread per task executor. It's a new task executor that creates a lot of that allow us to create virtual threads, and then we can submit our tasks the similar way we used to do earlier. So change in terms of change is very limited. We're not doing a lot of change in terms of code. Just we are changing the one line over here, and now with this program we can achieve the goal, which is I can create 1 million of threads. And in this program, which is I have shared over here, as you can see, the program's name is Gazillion Virtual Threads. We can in fact create a lot of threads over here. So the number is basically it's creating a lot of virtual threads, and the idea over here is whenever we get a task, I'll create a virtual thread and then execute that task. Once it is done, I'll just die. The thread will die, and new task will come. Another thread will will create another thread, and thread will die. But in executors, we keep thread, right? We keep in a pool so that we can reuse the threads. But in the new era, which is where we are going to use virtual threads, we're not going to store any threads in a thread pool or cache or any places. We are basically going to create a new thread to execute a task, and then once the task is done, we're going to throw it away. So garbage collection is going to take care of it. So over here, basically, we're creating a lot of virtual threads. But then once the work is done, it's the garbage collector is basically cleaning that up. That's why number is high. But in reality, we in fact can create 1 million of threads theoretically. Probably we are not going to do that, but it's doable. So that's why the advertisement which is let's create 1 million thread is quite accurate. So for good, let me know what do you think. Okay, let me go back to my slides because I got a little bit off, off to the topic. All right, so that's where that's where I wanted to come in this slide, which is Project Loom. Project Loom basically offer a threads, a lightweight virtual threads, which is cheap, which is can be which is we can create like instant, and then we execute a portion of code. We give the thread basically thread gives an execution environment. We put some code into that execution environment. When it is done, the execution is done, thread is also done. That's the idea. So now that we have virtual thread, the earlier we have another kind of thread, which is we could call platform threads, or since it's a equivalent of the operating system thread, so we can call it a platform threads. So now that we have two kind of threads, we can give a name to them. So the new kind of thread, which is called virtual thread, and the other kind of threads, we are not removing the other kind of threads which is currently used. They are going to stay as it is, but virtual thread is going to run on top of those threads, which is I have showed the demo earlier, right? So those threads are called now area threads. The reason is virtual thread is going to run inside those area thread. Think about it. I have a thread, I have an execution environment, which is basically equivalent of operating system threads. Now I have a new virtual thread, which is very lightweight. You can think of a Java object, and this thread is going to execute in this real thread, which is the carrier thread or platform thread. And then once it is it is probably blocked by network call or file IO or something. It is going to be yielded from the carrier thread, and someone will take place. The same way the executor framework works. What we do in executor frameworks, basically, we create let's say hundreds of threads, and then we keep submitting tasks. Um, so whenever one task is done, so this thread is getting reused by another task. So let's say I have 100 threads and I have 1,000 tasks. I'm continuously submitting. So one thread is done working with the particular task, and it picks another task. So that way it keep executing. So similar concept in virtual thread. The idea is virtual thread is basically it's similar in terms of you from our as a developer will probably not distinguish much in a programmatically platform thread and virtual thread. Both of them has similar similar things. For example, instance of thread, but the difference is virtual thread is going to be executed in the platform thread that we showed earlier, which is also called carrier thread or native thread, whatever you name it. So that's the two distinction we need to remember. All right. So creating virtual threads is pretty easy. You can do that by thread.state virtual thread. It will create a virtual thread, and you will get this. You will get a print something like that. This is one way, and there is another way is you can there is a factory method called thread.ofvirtual and then .unstarted, and then it will give you an instance of thread, and you can start that. That also another way of creating virtual thread. All right. So over here, if we need to create a platform thread, now that we have a two type of thread, right? One is virtual thread, one is platform thread. We can also create the regular thread using this, this factory method, which is thread.offplatform.unstarted, and you can provide whatever code inside this unstarted method, which is basically takes a runnable, and then you can start. So there is two way of creating threads now. So for any questions, let me know. I'll probably see over here.
Yeah, Danilo asking, so we can safely handle virtual threads as a disposable instances. I think that when the virtual thread is done, probably the
Yes.
garbage collector
Yeah.
will get it.
The answer is yes. So basically, virtual thread is a disposable unit of threads. It executes certain things, and whenever it is done, it is just it is die. Operating system is going to sorry, the garbage collector is going to take it away and crash it. So that's the idea. I can think of it as a task. Nowadays, we send a lot of tasks to executors, right? That's how we do. So, but you can think of I have a task. I'm gonna send it to virtual thread, and virtual thread is going to execute it. And once it is done, I'm just done. That's the idea. All right. So let me take another question. Is Loom is ready for production? Probably not yet because it's not available yet, right? It's still in preview phase. So in JDK 19, and JDK 19 is not released yet. So if JDK 19 is going to release in September, and it is going to be released as a preview feature. So it's an ongoing process. A lot of things is going to come, or a lot of things may change in meanwhile. So, but as a developer, we are very curious about it. So um, so yeah, definitely. The another question is, does the executor already creates and dispose as many threads as we needed? So executor framework, like, let me go into the IDE a little bit. If I can show you over here. So the idea is, let's say this is the executor frameworks, right? So over here we have, basically we create thread pools, right? We create thread pools in a different settings. For example, if you create 10 threads over here with a new fixed thread pool. So what I'm getting over here is a thread pool with 10 threads. These 10 threads will keep running, and whenever we submit a task, it's going to execute it by one task, right? Uh, that's the way you currently do. And this thread, this 10 thread is going to stay there for as long as we don't shut down this thread pool. Let's say there is a method called shutdown. Once we shut down this all the 10 thread is going to die out. That's the idea, right? Similarly, for virtual threads, there is a new there is a new virtual thread or task executor. This is for virtual thread. Whenever we use these services, for these executors, these methods, it's available in Java 19. Again, it's a preview feature. You'll probably not gonna find it this in JDKs, which is 17 is LTS and 18 is released recently. So service, and if we submit a task, new runnable, whatever task I'm going to submit over here, hello world. Or let's say I'm gonna print the current thread, system out print thread current thread. So this code is going to execute by a virtual thread, and this, whenever we submit method is going to create a new virtual threads. That's the idea. All right. So okay, so is there any already a scheduled executor service implemented the virtual thread? So far, I know about this method, but I am not sure about the scheduled executor service or not. I am not sure about that, but I'll definitely look into it, whether they have created something like that or not. Okay, so all right. Now, okay, so first of all, we have been talking about this whole things about which is virtual thread, right? What the question is, why do we need virtual thread? One is one explanation is I have given you so far, which is we want to increase our application throughput, right? And then so that we can handle more users. But internally, what it actually happens is, let's say we have a new executors fixed thread pools over here, which has a thread, which has a 10 thread. So let's say we are submitting a task over here, new runnable whatever. And this runnable, what it does is call a microservices. It call it microservice, right? So, and microservice probably take 300 milliseconds to get a response. So while this microservice is being, getting response, so this whatever thread is, executing this portion of code is basically blocked, right? And this thread is literally idle. It doesn't do anything, and it just stays there. Now let's say since I have a 10 thread over here, and I have 10 similar calls, and all of them are taking like 300 milliseconds. So at a point of time, my all 10 thread is basically being idle. They're staying there, and they're not doing anything because they have nothing to do, and without waiting for the other microservices to return a result. When they return result, they do the execution. So the idea is, if we create a graph over here, something like that. So this is probably a executions, call a method, invoke a method, and we invoke a method, and this method basically call a third party, so let's say microservice. This portion is probably, let's say, 10 microsecond, or let's say 1 millisecond to invoke a method, and rest of 300 millisecond is basically is going to be waiting period, right? Because I'm not getting results. Once I got the result, I'm going to then process this result, let's say, in another 2 microseconds. So the idea is our thread is all the time, most of the time, is basically waiting, and our resource is being wasted. So what if there is a way, whenever we get a this sort of blocking situations, we remove that blocking situations, and thread is going to execute something else. Thread is going to be busy always. So virtual thread exactly does the same thing. What it happens is, let's say I have a platform thread, it's going to be executed all the time, and I have a virtual thread, and virtual thread is going to call a microservices, and it sees that the microservice is taking long time, it's blocking. So platform thread is going to yell this virtual thread, and the stake is going to, the information is going to store somewhere, and meanwhile it will take another virtual threads to run. So that means one virtual thread practically, sorry, one platform thread practically run a lot of my virtual thread, because if virtual thread sees something blocks, let's say IO call, or something network call, it will yell itself from these executions, and it will be paused, and meanwhile the platform thread is going to do something else. That way we are not going to waste our resources, and rather we're keep doing something else. So that's the whole idea. And one thing is, we have to keep in mind that virtual thread is only applicable, only beneficial when we have a blocking situations, like we have a network call, we have a file IO operation. If we want to compute something like CPU intensive work that doesn't has any blocking operation, then virtual thread is not probably no, virtual thread is not even going to give you any performance benefit. Rather, it will give you the it will it will operation will be less performant. So two things we have to distinguish over here. One is two kind of work we do in our computer, in our program. One is IO intensive, which is call it another microservices. Another is CPU intensive. Let's say calculate let's say calculate prime number, or merge uh, merge an array, or sort an array, let's say. So for CPU intensive work, we are not going to get any benefit from this virtual thread. Rather, if our work is like CPU intensive, let's say I want to download 10,000 images, right? Then probably it's a good idea. So let's say I have a method like something like that. I'm gonna create over here. Let's say download images. Let's say I'm gonna create a method over here. So I'm gonna pass an integer over here, ID. So that's the ID of an image, right? And and I'm going to run, in this in stream range 0 to 10,000 and map, let's say for each, right? Item index. Okay. So if I run this program like this way, this portion of code is one single threaded, right? Because it's just a for each loop. It's going to run parallelly, sorry, sequentially, one by one. So it will download first image and then it will download another image. So while it's downloading, there is a blocking operation because it's going to call another network call and it's gonna wait. So what we're gonna do? Let's say I'm gonna submit this task to thread pool. This thread pool over here. Submit, download this image. Let's say, okay, so I'm gonna submit this. Now, since we have a 10 thread over here, so 10 requests is going to, add, uh, this now become automatically a multi-threaded program, right? So at a time we're gonna send 10 images, 10, we're gonna invoke 10 downloads because we have 10 threads, right? Over here. So these are the platform threads. What if those are not platform threads? Let's say, uh, virtual threads. In that case, if we create a virtual thread, now we don't have a limitation. If we want to run, 10,000 images, all of them are going to be, sent, let's say, simultaneously. And let's say over here, when index is 1, we submit a virtual thread. Sorry, we submit a task, a new virtual thread is created, and virtual thread sees that I have a waiting period. I'm blocked by a network call. So it will automatically yield itself from this thread, and so that another virtual thread take its place, and start working. So if we have this sort of situations, we're going to get really, what do we say, huge throughput. So and that's why virtual thread is extremely useful when when we have a situation like web applications, serving, sending request response, because a lot of the time we're going to idle. We have a lot of blocking operation. Let's say I have to query a database and it takes some time. I have to create call another microservices. That also takes the time, right? So that's the idea. Let me know if you have any questions so far.
Hey, Bazlur, we got a little question from Leonardo. Leonardo is asking, let me see. Hold on, please. Do you know what are the implications of the using virtual threads in a reactive model? Do you have some insight about that?
Okay, so I'm going to come on that topic in a bit, but
Okay.
in a bit, but I can give you a quick answer, which is what reactive programming does. Basically, it does the same thing in a way that there's a coin, there's a asynchronous system, right? We The idea is, let's say I have a thread full, and then sorry, not threadful. I wanted to say something else. The So bottom line is, let's not go down to that area. The bottom line is reactive programming is going to solve our problem. In fact, it's solving our problem because we have a limited resource. We don't have a lot of threads, but reactive programming helps keep busy all of those threads so that we can serve more users. That's the idea, right? Uh, Similarly, virtual thread is going to do the same thing. Only benefit is our programming model is now more easier. If you want to write a reactive program, you can see, you immediately can see that the programming model is extremely concept. The code that you write, and then you cannot execute that on your head. It takes a lot of effort to understand in a code of a reactive program, because you don't know that which thread is executing what, because it's a pipeline, and you start from here and you go over here. There's a lot of transformation going on inside, and each of transformation is executed by different thread. It's take a lot of effort to understand the whole flow. But if you use virtual thread, there is another concept which is going to come in few slides, which is structured programming, which is also going to be an interesting topic. But I'm not sure if I have time to explain that. The high level idea is your programming model is going to be similar. I mean, you can whatever you see in the code base, that's the exact programming model, and it's going to give you the same benefit which is reactive programming gives you. But your programming model is going to be easier, much easier. You can reason about it better, and then if you want to debug it, it's going to be easy, because you will have a thread dump. You'll see which push, you will have a stack trace, right? You'll be able to see where the call graph. Those are the benefits. But in a reactive programming, I don't know if you ever debug your reactive code. You will never you will get extremely hard time to debug a reactive programming code. So those are the benefits of virtual threads. Outcome is pretty much similar, but the programming model is much simpler compared to reactive model. That's the answer.
Okay. Thanks, Bud. Go ahead,
All
man.
right. All right. So hey Max, let me know how much time I have, so that I want to.
Well, I can be here. I don't know if you have some need to leave, but it's interesting topic. So feel free
All right.
to go ahead.
All right. So yeah. So now let's say how do we if we want to try out this virtual thread, how can I do it? First of all, it's still in preview feature. So you need to just download the JDK 19, which is available in Project Loom. Let me find that for you. Project Loom. Okay. So looks like let me sorry. Let me find that for you over here. That's the site where we usually go to download. Okay, the site is currently under maintenance. That's interesting. I didn't know that. Okay,
Yeah,
so
it's
there.
interesting. Some
All right.
the
So,
demo time it's hard, man. Sometimes.
so that's the project ZDK 19, and there should be. Okay, that's the repository that probably you don't want to go there, or if you're really interested, you can definitely go over here and download it. But ideally, it should be downloaded from um, Project Loom. Loom over here, and if you go to the wiki, so that's the place where you are going to get it. But since the site is under maintenance, probably you'll get it tomorrow, or I hope they will they will update it soon. Uh, all right, so that's the place we're gonna go and download the JDK. I have downloaded it a couple of days ago, and I've been playing a bit. So whenever you wanna run it from your command line, so you need to add this flag, which is under which is release 19, and then enable preview, because it's in preview feature, and the name of the class, and these are the way you are gonna you also can run from the JShell, which you need to enable preview as well. All right. So now the question is how it works internally. Do you wanna know about that? I mean, it's going to be okay. Before going here, there is a question which is there a new calculation to get a max number of thread for our app optimally handles different from Banker's formula? I don't know about that. The reason is it's still new, it's still in progress. So we are not you know we're not in a place to come up with this sort of formula yet. Probably once it is stable enough, then probably we'll have something like that. So the answer is at least I don't know, but you can definitely do an experiment and try out and see what is the result. So yeah, sure. All right. So this one is a bit involved. Um, I'm not sure if you are interested in this, but I can give you a quick idea. So the idea is, let me go into a example over here. So there is a thing called continuation in JDK. It's super secret. It's extremely hidden from us as a developer. As you can see, it's an internal, and you know since it's an internal, you are not allowed to touch or use any of these things. So it's a secret class, and only JDK, JDK developers can do anything about it. Mm, and idea is in your regular life, day to day life, you are not supposed to use this, and you don't even need it. So, but to understand, to give you an idea, I probably want to show you, which is what it actually does. So idea is, let's say I have a continuation over here, right? I have created an instance of continuation, and then I have created a scope over here, and I gave a name over here. That's all. So inside the continuation, you see I have created a method call, created a line. I mean, it's a print statement, which is C1. And then once I'm done over here, third line, what I did is I yielded over here, you know, continuation dot yield, and that is scope. And then I have, created another method over here. Sorry, another print statement. So over here, basically, we have executed three statement. Okay, so that's the continuation, right? And that's okay. We have defined this continuation, and we defined this scope, and we have added, the method, the code that we want to execute it. We define everything over here. We are done. Now over here, we are in a thread, right? Over here, we are in a main thread. So curly braces start and end over here. Whatever we run inside this curly braces, we're gonna get executed by a main thread, right? So what I did is, uh, that's the line I'm going to run by main thread, and then I call it continuation.run. Once I call it continuation.run, this continuation is going to get executed. That's the expectation. And when I go over, sorry, not over here, go over here, and I see a line over here, which is yield. So what it's going to do is it's yield itself. That means it's no longer going to continue the executions. Okay, so that's the idea. Then I'm going to run this method, and then I'm going to call this run method again. So when I'm going to call this run method, what would happen? Any idea? It's a quiz. Let's see who can answer correctly.
Maybe the context will continue to run.
So which line is going to run again when I'm here?
I think that the 12th
Line
line
8?
will be executed.
Line 8?
I don't think so. I think that it is the last one. Am I right?
This one?
I think so.
Okay, your intuition is correct. That's how continuation work. So the idea is, let's say it started executing a line of code, and then it sees a line called continuation.el. It will pause this execution over here in this line, and then later it can be resumed. That's the idea. And then it will not, when it is going to resume, it's not resume from the beginning, rather where the point it stopped executing, and then it can execute from that place. So that's the idea. If I run it, let's see if I can run it. It sounds like it's running. Okay, so over here you can see I have a start method. That means I executed this line, and then I have run this method. I have called this method, which is continuation.run. That means the code went to this line, line number 8, which is great, and I have executed this line. And then when it executed this line, it came here. That means main thread got it back. Main main thread came here, and it does certain things, and then it runs the continuation again. So when it runs it resumes from here, not the first line, right? So that's the idea. So and then it runs the second line and it's done. So in virtual thread, exactly this is what happened. So you give a task. Let's say you give a task, and this task, started executing, and it saw a blocking operation. Let's say, I call I call thread.sleep, or I called a third-party service. Let's say network operation. So network operation takes some time. Then this portion of code is going to call itself continuation.el. So it will go away from that. So this thread is going, running this virtual thread is now become free. This virtual thread goes out of the picture. Now I can get another thread and start working on it. And if there is another blocking operation, it will yield itself and it will go away, and thread is going to be free, and another virtual thread is going to come. And then we can definitely later we can resume it, right? Whenever, let's say, network operation is done, then we can resume it and it will resume from there. So that's how virtual thread work. You can call it's a lightweight thread or user thread. It just internally this is what happens. So I just wanted to give you a quick demo what it happens internally. It's extremely high level. It does way more than that, but from the very high level picture, this is what it does. So virtual thread is pretty much but operating system doesn't see virtual threads, right? It's a JVM construct. So it's like another Java object, just it has a execution environment, and it can get executed, and then it can also yield itself from the executions and pause for a minute for a time being, and then resume it later. So that's the extreme high level. All right. So that's the idea. And for this particular virtual to be able to run this virtual thread, we have a fork join pool, which is special kind of thread pool that's been available from Java 7. And so basically let's say I have a computer which has 8 core, then it will create 8 fork join pool, and this fork join pool will basically going to responsible for all the virtual threads. All right. So just I already showed you the continuation demo. That's what I wanted to show you. The similar concept is being used some other programming language, for example Kotlin, Go, JavaScript, Python, Ruby, and finally we have now in Java as well. So that's a great thing. All right. I just wanted to go into these slides. So I'm just going to reiterate again what I have been saying so far, which is with the advent of virtual threads, threads are now chips, and the request per thread model of a server-side programming has become easy again, because you don't need to maintain any thread pool. Whenever you are going to maintain a thread pool, you have a headache, right? You have to tune the thread pool. How many threads are if we create too many threads, that's not probably going to hamper the performance. If we create less, that's also going to going to help us. So we always have to find the sweet spot. That's not easy. Sometimes we keep experimenting and then we figure out a sweet spot. now that with the virtual thread, we don't need to create thread pool anymore. Thread pools is dead with the virtual threads, and you don't need to uh, write reactive mind-bending programming. I mean, reactive programming is great, definitely, but the programming model is not easy. It requires it requires learning, and also and now that you can create millions of thread, that means you are going to get more throughputs. Ideally, you are probably not going to create millions, but theoretically you can create more than a million threads. Yeah. So the advertisement isn't, after all, false. What do you think? All right. So on a blocking operations, virtual threads that basically get suspended. It yields itself, and later it can resume it when the let's say we have got an interruption, or we have gotten a notification from network, something like that. I don't know the details, but yeah. So let's say when it is ready, it will get resumed automatically. And it supports all these interesting things, which is virtual threads are now support thread local synchronizations, thread interruptions, all those fancy, this interesting stuff that a thread provides, so that we can take a thread dump and we can analyze. We can, if we need to, let's say we need to compose a few tasks and it has a dependency, and if we have a mutation involved, we need to synchronize them, right? So we can do all those things we used to do with the platform thread, we can do in virtual thread as well. So basically, virtual threads and platform threads are the same thing. They are in a way mirror when we are dealing with it, or as a developer when I'm going to write it, our program. But internally, it's different. It's a different. One is cheap, one is costly. All right. So these are the extreme. These are the benefits. So I definitely wanted to discuss about um, discuss about um, structured programming, but probably it requires another hour. So I'm gonna probably skip it for now. But I just wanted to give you a quick demo. It's not a demo. I'm going to show you the code over here. So there is a two code over here. First one is using complete computable feature, and second one is using the virtual thread. Um, both of them uh, both of them are for creating downloading ten thousands of images, um, and this is the current programming model. And with the virtual thread, I'm going to get the right one, which is this one. And just tell me which one you think more easy, and that's all. That's a question for you. Sorry, left or
Let's
right?
see let's see if the people you're giving a bit.
So
Whether or
both
not
of
maybe.
them does the same thing. It downloads image from Wikimedia info, and let's say I'm going to download 10,000 images from here using this code, and then there's another code over here, which is we have using computable feature, which is asynchronous programming, right? Which one do you prefer most? Which one do you think better in terms of um, programming model, or how you can, I mean, when you read code, do you understand that code or not?
Oh, Marcelo is saying that the right one is more easy to read and understand, at least to me. I think so. I need to agree with him.
All right. Personally, I think the right one is easier. It's easier for me as well. I mean, it's the traditional imperative code, right? We know exactly what is going on. We created new virtual thread executors, and code is really readable. And over here, it's doing a lot of fancy things. I mean, we changed. I mean, a lot of developers really like this approach. I mean, it's interesting, but then it becomes a headache when you are, when you have uh, in thousands of lines of code like this, and it's whenever you want to debug something, it becomes really difficult. So with the advent of virtual thread, you can now in fact write code like this imperative age old way imperative way that we have been used to for many years. I mean, everyone has this experience, right? So yeah, that's personally, it's a huge benefit of having virtual threads, which we are going to enjoy soon.
It's
uh,
interesting. Marcelo also said that the last one has a lot of terms that are
you
somewhat
can
abstraction.
you can bring his comment into the screen.
Oh, great. I do also agree that the right one.
All right. So yeah, that's all I have for today. I'm not going to touch the structured programming today. That's going to be another time, probably another talk. There are certain limitations of virtual thread as well. So first limitation is, if your call stack is really high. For example, in a Spring applications, there are so many stays, and so many, the stake size become really large. That is a problem. um, you know but ideally, uh, um, you should treat virtual thread as a unit of work. You just give a task, and virtual thread is going to execute it, and then you are done with that task. So that's so you don't create a, I mean, if you have a few, that's okay, but if you have a lot of task that has a call stack like this, huge, that's going to be a problem, because the calls, the stack can shrink and grow. If it grows and grows and grows, that's going to be a problem. Okay. Okay. Right. So that's one limitations, and the other limitation is CPU intensive work. Like I said, computation work are not suitable for virtual thread. If you put a computation work, let's say calculate something into a virtual thread, it will behave the same way the platform did or usual thread behaves. So let's say you give a huge computation task to a virtual thread. It will going to execute it by a platform thread, right? Ideally, platform threads or carrier threads is executing. So since there is no blocking or IO operation, platform thread is not going to, or virtual thread is not going to be yelled, or it will keep running. So other virtual thread will not get chance to get into CPU time, some CPU time. So other thread is going to get in it starvation. So uh, CPU intensive works are really not suitable for virtual thread. I wouldn't say it's a limitation. It's if you have a CPU intensive work, you're not supposed to use virtual thread anyway. So I wouldn't consider this as a limitations. All right. Okay. The other thing is, there are other low-level details. A lot of one is preemptions. The current platform thread can, in an arbitrary time, it can pause and then unpause. Those sort of things is not available in virtual thread, but probably in future they're going to have it. So the benefits of preemption is, like I said, let's say one, you give a computation work to a particular thread, and it keep doing the computations. If you not preemptly pause it, then other thread will not get a chance, right? So that's why virtual threads computation work is not suitable. But if we have that preemption, operating system or the JDK platform itself, um, sorry, I mean JVM is going to preempt that virtual thread, and so that other thread can get some CPU time. Maybe in future they are going to add that. All right. There are other limitations. These are minor limitations, which is virtual thread cannot be created using public constructor. That means the kind of um, the kind of work uh, you know um, I mean, if you want to create instance of virtual thread, you have to use the factory methods available, not the way. If you want to create using constructor, you are always going to get a platform thread, or traditional thread or classic thread, whatever name you call it. But if you want to get a virtual thread, you have to use that factory method. There is no public constructor available for creating virtual thread yet. Okay, so virtual threads are by default daemon thread. They are not, you cannot turn them into non-daemon threads. Virtual thread, there is no way to change priority. So, and also thread group doesn't work. The reason is virtual threads are basically child. You can call them child thread or career thread or platform thread or native thread, whatever you call it. Yeah, and then virtual thread are not supposed to be pulled, right? You're not going to you don't need thread pool anymore, and you don't virtual thread are created one task. The idea is you are going to give a one task, and a virtual thread is going to execute that task, and you are over with that. You are not going to pull virtual thread a lot of virtual thread in a pool, because it's one time only. Why you are going to pull them, right? So you are not supposed to pull them. Okay. So the other thing is, in platform thread, threads are created on a stack, and virtual thread is created on a heap memory. So that means when you put something on heap, that's also adds work to garbage collector, right? Because when a virtual thread is done with its work, you have to remove that away from, so that you have to garbage collect it. So ZZ has now more work than earlier. So if you have a tons of virtual thread, that means the work of garbage collector is will keep rising. So that's another limitations. I mean, there are others, but these are the highlights. All right. So the other question is, it's a common question, most frequently asked question: do we need reactive programming? The answer is yes or no, both, because because the virtual thread is not out yet. It probably takes some more time to get used to, and although the JDK 19 is going to have it, and it's going to be preview, so to be able to include it in JDK, I don't say it's going to be in 19 or 20 or 21. I don't know when it's going to be a part of JDK. So let's say it's 21. So not everyone is going to move 21 from the day zero when it's released. People will take time. So reactive programming is going to stay there. But if we want to use the virtual threads and other, we probably don't need it. But there are other fascinating stuff in reactive programming. For example, breath pressure, change propagation, composability. You can change things. So those are, some people like them. So since those are not available in the virtual thread or current concurrent model, people, if want to use them, they are probably going to use reactive programming anyway. But it's definitely um, the need of reactive programming is going to be less. Maybe in down the road, next 10 years, or next 5 or 10 years, people are not going to write concurrent programming in reactive way. Rather, they're going to use the default virtual templates, virtual default concurrent model that Java has to offer. So yeah. All right. So there are some resources which if you want to go and dig into, you can definitely read those. And yeah, so that's all. Finally, what I would request you to, I am constantly learning new things, learning, experimenting those concurrency stuff, especially virtual threads and other things. If you want to keep updated, stay updated. You can stay connected with me through Twitter. So I share a lot of tons of resources, not just concurrency, all the things related to Java and software development. So I have a news, what do you call it, subscription things. Let me show you that. Which is over here. If you go to my Twitter account, there will be a subscriptions thing over here. You can subscribe. So it's a newsletter things. I'm trying to trying to start. So probably if you subscribe, I will be able to share a lot of content to you as well. And you can also reach out to me if you have any questions related to Java in general or concurrency, whatever. You can definitely reach out to me, and I'll try my best to answer. Even if I can't, I'll point to the right place where you can find those information. So that's all I have. Thank you. Let me know if you have anything else. I mean, if you have any questions.
Oh, it's awesome, man. Thanks for your presentation. It was so rich, but also it's very, there are a lot of things that we need to put on in my mind in the working and make those things easier to understand and to put on the place. So, but also I must thank you. And looks like there are some questions and in the chat, but I think that you answered everything. uh, Wesley asked if there is a place that you can get the slides. You can share your slides.
Sure, sure.
And
So I'm
you
going
you
to share. I'm going to share the link.
okay?
There's a
Send me
thing
an
called slide deck.
great.
Um, Let me share my slide deck links. It's probably
Oh,
in slide deck or slide share. I forgot. Let me share slide share
also
out here.
Leonardo asked me to send the links that you show in the resource slide. Am I right, Leonardo Sagala?
Okay, I'll
But I
share this slide with you, and you can link into the YouTube
sure,
page
sure,
so that
great.
I have uploaded slide somewhere. I forgot where it is. But yeah, sure.
Yeah, let's yes, it do. Let's text. Less text and more codes, please. Yeah. But it's awesome content. Maybe we can book another session, Bazlur, because looks like you have a good ideas regarding structure model regarding the thread
Sure,
in
sure,
programming.
definitely,
So
definitely.
we
I'm
can book a new one.
sure, sure. So I'm going to share my slide deck over here, which is over here. So
Yeah,
it's not slide speaker deck. So that's where I
great.
have uploaded the slides. So you can definitely find it over here. And yeah, sure. Let me know whenever you need me. I'm available. I'm excited about whenever you want to talk sorry.
That's okay.
I'm really excited about to talk about anything related to Java, and especially recently I wanted to talk about concurrency a lot. So anything if you want to, for example, lately I have given a talk to I have taken a workshop at Stumblejug. So if you're interested in essential training, then also I'm available. If you just tell me when you need me. I can give you the talk of essentials. If you have audience for that, let me know. Other than that, any
Sure.
topic if you are interested in.
Great, great. I ask you, you ask you. Don't worry. But send me the link in the chat in the private chat. I will send it in the chat. I will put that in the
Sure,
chat.
sure.
Please. And everyone, if you guys on the audience, if you want some question, please do it, or else we can close our session today. But I'm so happy, and I must thank you, Basler, for this opportunity to hosting you, showing this amazing presentation, this terrific presentation. Actually, I need to read again, and I need to learn more. I will reach out to you
Sure,
during
sure,
some class. Okay.
sure, sure.
Okay. So
Thank you.
go ahead, please. Sorry that
Uh,
my kids are playing video games near to me, and so they are
no worries,
they
no
are
worries. Kids are
screaming.
fine.
No.
They're fine. That's okay. That's totally okay.
Okay.
Uh,
Do you have some last words?
thank you again for hosting me. I really enjoyed talking, with SouJava. So hopefully I'll talk again in future if you invite me, of course. All right. Till then, take care.
Hey guys. So bye everyone. Have a good night, and see you the next time. Bye.
Bye bye. Bye bye.